in our session, we will be looking at the company introduction, as in where and from where MIDAS Software Solutions is, and for how long are the softwares being developed, and how many softwares or what all softwares does MIDAS has to offer. Then we will look into the introduction to MIDAS Engine Software Solution, which is our building and general structures package. We will look at its strengths, and at the same time I will be showing the demonstration of this mall type of a building. And then I would like to tell you about the support service that MIDAS has to offer. Lastly, we will conclude our session, and then we'll take up the question answers. So without any further delay, I would like to begin with the introduction to MIDAS. MIDAS was established in the year 1989 by POSCO Group, and since then the softwares of MIDAS have been distributed in more than 120 countries. There are 540 number of employees, 18,000 number of clients, and more than 40,000 number of users worldwide. MIDAS has its headquarters in South Korea. So the origin of MIDAS is South Korea. It's a South Korean software, and all over the world there are 9 branches. One is in China, USA, India, Japan, UK, Russia, Singapore, Philippines, and the UAE. Coming to MIDAS business areas, MIDAS has 2 main business areas. One is in engineering consultancy and the second in software developments. Depending on the consultancy requirements, the softwares have been developed for the fields of bridge, structural, geotechnical, and mechanical engineering. Coming to a partial list of our users, these are some of our local clients in Africa. So you might be knowing few or all of them. Some are into private companies, some are government, like TAN roads. Some are small scale companies, some are big scale companies. These are some more local clients of Africa. Basically, our MIDAS software solutions include the bridges, structures, geotechnical, and mechanical. So the clients that you saw, they are using either or some of these softwares. So I would like to talk about the bridges software solutions first. So we have MIDAS Civil, which is very famous all over the world for an integrated solution system for bridges and civil structures. You can very easily, very efficiently, by saving a lot of time, model the simple bridges to complicated bridges like pre-stressed, cable stayed, extra dose bridge, and so on in MIDAS Civil program. You can perform the analysis as well as design in MIDAS Civil. Then coming to MIDAS FEA, which is our advanced nonlinear and detailed analysis system, wherein you can perform contact analysis, you can perform total strain crack analysis as well, and so on. Then we'll come to the structures part. In structures, we have MIDAS Engine software solution, which is an integrated system for buildings and general structures. Today, I will be demonstrating and explaining about what MIDAS Engine is available for. Then MIDAS Drawing is a software solution that provides detailed drawings, or it's an auto drafting tool. And we can also generate bill of materials from MIDAS Drawing. The design results from MIDAS Engine can be taken into MIDAS Drawing and easily generate the entire longitudinal rebar details and even bar bending schedules. Further coming to the Design Plus software, so there is MIDAS Design Plus, which is our structural component design and detailing tool. So if you are interested into performing design of beams, columns, shear walls, base plates, bolt connections, and so on separately into a single software, then this is the one. Okay, so that's about the structural solutions. Now coming to the geotechnical part, we have 3D and 2D geotechnical software solutions. GTS-NX is a famous geotechnical software solution of MIDAS, and SolidWorks is a 2D finite element software solution, and it also can perform analytical geotechnical analysis. So that's about our geotechnical solutions. Then mechanical softwares, in which we have MIDAS NFX and MIDAS FX Plus. So NFX you can use for in the civil engineering field for, let's say, 3D computational fluid dynamic analysis, or even for impact analysis. Okay, so let's move on with the introduction to MIDAS engine now. MIDAS engine is our next generation solution for building analysis and design. It is an all-in-one solution, which means that it comprises the analysis tools, design tools, as well as the drafting tools. You do not need to use 3 different softwares to complete an entire project. MIDAS engine will take care of everything. Let's look at the design codes that MIDAS engine has to offer. So we have got automatic load options for wind loads, for seismic loads. That means we have Eurocode, British Standard, and in RC design, we can see there is again Eurocode, British Standard is there, American Standard is also available. In the steel design as well, we have British and Eurocode. We have mesh design. And for advanced analysis and design options as well, we have SRC and cold form section designs that would be available in MIDAS Design Plus. Coming to the standard design codes. So this is again for our structural solutions. Now, when we talk about MIDAS engine, we can completely have an integration with the BIM tools. So Revit Tekla models can be imported in MIDAS engine, and also as an output, we can take the results in the form of CAD. So MIDAS drawing is there to generate the drawings. We also have MIDAS iCAD, which is a similar tool like AutoCAD. Of course, MIDAS engine can give outputs in the form of DWG files. That means you can use those files in AutoCAD as well. So that is a complete import-export integration of all these softwares for analysis and design purpose, as well as modeling. So all in all, MIDAS engine has integration, automation, optimization, and high-quality outputs. And you can actually start from architectural drawings and generate structural drawings. So it's a drawing to drawing solution provided by MIDAS. Coming to the strengths of MIDAS engine, we will talk about the integration part. Integration as in MIDAS engine has got modeling, loading, analysis, design, and outputs all in one software solution. When it comes to modeling, there are easy and fast CAD-based modeling tools available. We can do tracing of our sections as well. Loading, automatic load calculations for the wind loads and seismic loads is available. Analysis, multiple analysis cases can be generated in one single software for one single model. Even for design, we can have multiple design cases. There is optimal design as well, which will include the rigid zones of the beam between the beams and columns, as well as the columns and the mats. Then output. When it comes to output, we have got high quality reports generated in the form of Word file, and also drawings generated in the form of DWG or DXF, as well as we have the bill of material output, which is generated in the form of Excel sheets. So all usable softwares are included. Let's look at some automation features regarding modeling in MIDAS engine, and that's starts with the tracing. So we have got tracing option wherein you can actually trace all the columns. That means you do not need to actually define the thickness or the section sizes of the columns. You can also trace the location of the beams by merely using the lines from the architectural drawings, center lines. You can even manually draw the beams. Manual CAD-based tool drawing options are also available. Then slabs also can be modeled. And you can create openings. So that's an automated CAD tracing function. Then there is CAD-based modeling tool wherein you can easily do moving. You can do copy. You can change the size. You can use extend, trim, and you can also use irregular shapes to create openings. When you have, again, a shell element probably of irregular shape, you can see how easily we can do the modeling. This is all available in MIDAS engine. We have sweeping feature. Plus, when it comes to meshing, the program can do auto mesh. If you want to reduce the mesh size, you don't need to delete anything. Just change the mesh size and the mesh is modified. So that gives us more accurate results. All types of foundations are available in MIDAS engine. So you do not actually have to use multiple softwares for the superstructure and the substructure and the foundation. One software solution for all types of members. So apart from the beams, columns, shear walls, we also have basement wall. We have the footing girder, which can be used for, let's say, plinth beams, and pedestals are there, which are required below the steel columns. And we have isolated footing, mat footing, strip footing, and also we can include piles. So pile arrangements are easily available. You can provide the geotechnical data for the piles, and the spring supports will be applied below the mat foundation or the pile caps. So that's about the automated functions in the field of modeling. Now, when it comes to loading, there is wind load option in MIDAS engine that can automatically do the calculation as per European standard, American standard, as well as British standard. So you can see there is option to apply the wind loads for general building structures. You can also apply to enclosed type of structures, the ones which have pitch roofs, dual pitch roofs, then open structures, and you can also apply to equipment type of structures by converting the loads from the by creating the loads from the reactions. So there are some options available that can be efficiently used in MIDAS engine. And again, for seismic load, there is application for static seismic and response spectrum. Okay, so yeah, that's about the automation feature. Now, before I move ahead to the optimization, let me go to MIDAS engine software and show about all these automated features. So I'm going to be opening MIDAS engine software solution. I will be introducing you to the interface of MIDAS engine. So I'll open up a new file. Alright, now MIDAS engine has ribbon menu at the top which is divided into different tabs, and all these tabs are arranged as per the work procedure from left to right. So there are first 4 tabs for the modeling, then you apply the loads, then the boundary conditions, then perform the analysis, perform the design and check the results, finally generate the outputs in the form of Word files and drawings. Then further we have got the tree menus in which we have model tree menu that gives information regarding all the modeling functions, and analysis tool tree menu which gives the load information, boundary condition and the number of analysis cases. Design which gives information regarding the design groups and design cases and rebar arrangements. And further we have a display tool that you can save your views, and we have a table tree menu that can generate tables for all the inputs and the outputs. Then we have properties dialog box that gives us information regarding a selected member. We have a message window at the bottom which gives an intuitive information regarding the errors or warnings. And we have got over here the auto intersect option, and we have got unit system which can be modified in the pre-processing or post-processing basically anytime. The user interface consists of 3D, plane and story mode that makes it very easy to do the modeling, and you can access to any view by simply clicking on the middle button of the mouse. Now let's move ahead to the modeling part. In the modeling, there are several functions available. We have got importing function, which includes text file import. So your models from Revit Tekla can be imported using this MGT file. Then stat file can be imported. If you have irregular shapes, you can import those using Parasolid. And 2D as well as 3D DWG or DXF files also can be imported. We can use tracing file option, which means that you can trace architectural drawings in MIDAS engine. There is grid line method as well. This is a 3D grid line, and good part is that you can convert these grid lines into members. So a lot of time is saved in creating your members using the grid lines. You can also use simple CAD-based functions to generate the columns and beams using coordinates. Another method of modeling is by using sketch. You can sketch the entire structure and convert parts of it into members. I will be using the tracing file function. So I'm going to import a tracing file. Okay, so I'm going to have one for the ground level, one for the second or the first level basically. So I'll click on OK, and I'll go ahead and create story. So right now I'll create one story and I'll replicate that story. So let's add one story of 4 meters height, and I can click on OK. And then further, we can just click over here on 1F tracing. Basically, we are placing our architectural drawings on that floor level. After that, we can simply go to the story and then to the members to create our columns or to trace our columns. So let's use the material. By default, European standard materials are applicable or available in this file, in the new file. All you have to do is simply make a box around the entire structure now. The program is detecting all the section properties by simply understanding the periphery of the columns, and the height will be taken automatically from the story definition, and then click on apply. So we have got our columns ready, and similarly we can create the walls. So walls, again, we have got membrane type of wall, plate type of wall, that means it can take in plane as well as out of plane meshing. And again, similarly, you can trace the walls and you can click on apply. So even the walls are generated very easily. Now we can also generate our isolated footings. So this is available. We can just go to the top view and we can use a thickness. Well, if you are using, let's say 700 mm thickness for the isolated foundation, then you can go to this thickness tree menu and add a thickness of 0.7, and we can go ahead again for the isolated footing. Now you can see how easily we can generate these footings. I use the thickness, and then there are some analysis methods available. So I'm using the FEA method right now, and here I specify what is the length and breadth of my footing. So I'm going to be providing over here 3.5 meters as the length and breadth likewise, and then I can simply select my columns. So whichever columns I want, I can select them and I can click on apply. So I have actually applied over here the information. There are some overlaps, so you can actually see the overlaps, and these overlaps can also be merged. So if you want to do merging, again, it's an easy function available in MIDAS engine. Simply select with all these and the program will automatically do the merging of the isolated foundations wherever required. So they will be combined or isolated. Okay, so this is how easily you can do the merging of overlapped 2D elements, okay, or 2D members, be it slab or be it a foundation. Now another one I would like to show is the mat footing. Very easily we can create this mat footing. All we have to do is click on the periphery. So let me just click on the periphery and provide a distance or an offset of, let's say, 1.5 meters, and I'll just press enter. So here we have our mat foundation as well. I by mistakenly selected T150 and make it as T700. Okay, so we have got our mat foundation as well generated. All right, so till now we have created our foundation, columns and shear walls. Now we will move ahead to the next level wherein we will be tracing the location of our beams. So I'm using the section size of 400 by 600, which is by default in MIDAS new file, engine new file. I'll just select the entire floor plan wherever I want. I can just select that location of my center line, and I have got my beams also generated. I'll create my slabs as well. So here I'm selecting thickness of my slab as 150, and then analysis type also. We have plate in out and membrane type as well. So if it's a conventional type, then membrane type of slab would be applicable. Again, over here, I just have to select all the periphery elements and then click on apply. We can see the preview before applying any slab. Okay, so we have got our members. There are locations where we do not need these slabs. So I'm going to be deleting those locations. So here as well as over here, I'm choosing to delete the slabs. Okay, I think this is not the area. This one is where I'm going to delete. Okay, so these are the areas where I want to keep. We can even easily do the division of slabs. Now this slab can be divided with the help of this particular beam. So this is also one option available. You can select the slab and select the tool over here and click on apply. So I've got two slabs divided. Slab divided into two. Okay, so we have got right now our slabs, shear walls, columns, and foundations. Further, let us go ahead to replicate our structure or our first story. So I'm going to use this add option and I'll add some 3 stories. So we have added 3 stories and we can see it intuitively. We can modify the floor to floor heights at any point of time. So if you want, you can change it to 3 meters, 3 meters, and 3 meters, like as required, of course. And you can click on OK. So the height also modifies accordingly. All right, so this is about the entire RC structure. Now let us also see how steel structures can be generated. So what I'll do is I will trace the columns at the roof level right now. So I'll go again, trace some columns at the roof level. So here I'll just trace these. So basically I'm creating the locations where I want to place my roof truss. Okay, so I've selected all these options and these ones too. And I'll provide a height over here of 2 meters. And then I'll click on apply. Okay, so I have got my 2 meters columns. These are RC, however, I can just change it. I can select it and change the size. I can keep it as UC 305 by 305. So I've got my steel columns ready with me. Now I will go ahead and import my truss. So this importing function is again useful. So I'm going to be importing a DWG file. It's a roof. I'm going to import the roof truss. And this is going to be at a height. Okay, height, let me check the height. We have got, as per the story, 14 meters is the height. So 14 plus 2 is 16. So for 16 meters, I'll be importing at 16 meters. Import DWG DXF roof. And this will be 1. And it will be at 16 meters. We can see the preview and then click on OK. Alright, so we have got over here our roof, and this is actually just a drawing, a sketch. We can actually select a part of it or parts of it and convert them into members. So here I'm going to, while importing as well, we can actually select layers, different layers for beams, struts, bracings, and assign them the section properties. Okay, so over here I will simply select and convert my body type of elements into members. Okay, so here it'll be actually very easy if I simply select all this and just say show only, and then I'll convert the members. So I'm selecting these, and I have got the polygonal selection option as well to make this selection of the curved roof. So curved type of roofs, curved type of slabs, all these options are available in MIDAS engine. You can do any irregular shapes in MIDAS engine software solution. So I selected this and I'm going to convert it into, make it a C section. So I'll click on apply. So steel sections as per the code are also available. Now I'll create my struts as sub-column members, and I'll use angle section for my verticals of my truss. So I'm going to use this pick selection. So I'll actually try to make this once, and then we will see how the rest are created. So I'll just show an example here. So I've created my truss, subcolumns, and now I'll make a truss as well. So bracings will be truss type of elements, again using angle section. So here I will just unselect all and select only the body curve. I'm using some selection filters to easily do this selection, and that's it. So I've got my truss members, I've got my struts, I've got my beams as well. And now I can simply copy this information to all the locations. So I can use my copy command from the left view. I'll make a selection of all these members. And to do copy, again, there are options available. I can use my 2 points option, or if I know the unequal distances, then we can also actually provide that information. So I'll just quickly do this generation. Okay, and then further we can go ahead, create beams, and I'll use a UB of 300 by 500. So by simply clicking from the start to end point, I can still ensure that all my beams are divided. Okay, so similarly, I can create from here to here. Okay, I will again create my purlins now. So purlins I'm going to be using, of course, we can define another section property. Now sections can be easily defined in MIDAS engine software. Even irregular section shapes can be defined very easily. So let me show you about how firstly we can create all the steel sections. So we have got a database for British standard, for IS standard, as well as American standard is available. We can select all these different shapes that are available in MIDAS engine. So I'm going to use a channel section of 100 by 50 by 10. I can insert this template. We can do modification of this template as well, and then we can click on apply and close. And if you want to sketch any irregular shaped element or member, so you can simply do its sketching here. So like this, you can do the sketching of any shape, and you can select this, click on OK. So a section is ready, which you can actually utilize directly in your analysis. Okay, so I'm going to close this, and we are going to be using our beams again. You can use them as sub beams also, the purlins, and you can select the latest created PFC section. So I'll be simply clicking on one node to the last node. I will copy this information actually to the rest of the areas. So I'll just select this purlin. The purlin has got the offset as center top, but we can actually change it to center bottom, and you can see how it has gone up. Okay, so anyway, we can modify its properties at any point of time. So I'm creating these purlins. I'll copy these purlins from one location to the other as required. I'll create one for this, and then we will see the final model generated. This is just for showing how we can easily do the modeling. Now I'm going to be creating a roofing. Now this roofing has a new material property. So you can actually input your user-based material property over here with the modulus of elasticity and the weight density and the tensile strength. But this is a design part, so you're definitely not designing the roofs. So this tensile strength and yield strength won't matter. So just click on, we'll provide over here as roof as the name, and click on OK. And this can be further used to create a thickness. I'll create a 0.003, 3 mm thickness for the roof. And then we can simply use this information to create our roof. Okay, So I'm going to be simply selecting the objects. All I'm going to do is select the periphery. So I'm doing that right now. So it's basically going to be detecting all the peripheries and the slabs. So there are many slabs over there on the roof, of course. So I'm selecting in this way. And this one. This is optional. If you do not want to create the roof, you can apply the load of the roof directly on the beams, on the purlins. So that option is also available. Okay, so finally I have selected all the periphery beams to create the roof, and I'll click on apply. Okay, the slab membrane was selected, sorry. So basically that was the option. So I'll just quickly do the selection of few so that you can understand how this can be generated, and then I'll open up the modeled file. Okay, so just click on OK. Okay, so this is how you can generate the roofings, and this can be copied to the rest of the part. All right, so once the entire model is completed, you can see it all completed, and then you can go ahead to the loading part. So in the loading part, again we have got options to easily generate the loads, like self-weight is there. I'll click on OK. So self-weight is applied. Now coming to the slab loads, so I have got my slab load type option, in which I can include both my dead load as well as my live load. So instead of like selecting multiple times these slabs and selecting different load cases, I can do it directly. So let's say it's 2.5 as a floor finish, and minus let's say 4 kilonewton per meter square is the live load. And then I can simply apply both the dead loads, I mean the floor finishes and the live loads, to all the selected slabs. So actually this becomes a faster option. You don't have to select the same slabs again and again to apply two different sets of loads. Okay, now we will move ahead to the next part, that is automatic calculation of wind. So there is wind load option available. You can have for enclosed area, open areas, equipment type, or story based. So when it comes to an RC structure, you can use simply the story based command. And in case of the equipment, or rather over here we have got steel sheds. So in case of steel sheds, you can use this enclosed area option as well, wherein you can use the curved roof calculations. So you can select all the windward walls, leeward walls, roof walls, and so on. So that's the information which can be again automatically calculated by the program. So here, as per the European standard or the British standard, we have the option to manually automatically get the coefficients for the internal CPI, CPE. For the roof, we can calculate the coefficient, and also for the friction, these can be automatically calculated. So if I just provide over here the information, you can see, let's say the major and minor is 60 meters and 30 meters likewise, and then we can provide if it's a flat roof, monopitch, duo pitch type of roof likewise, and if there is any dominant phase or not, and the friction, so smooth, very rough, or rough type of options, these available as per the Eurocode are there. So if you just select all that information, then the CPE, CPI calculations can be automatically generated. You can manually also apply this information. Yeah, the structural factor also can be automatically calculated by the program if you provide its natural frequency. So for natural frequency, you need to perform the eigenvalue analysis. When it comes to simple story-based structures, we have the option to again calculate the wind load. So we have got European standard as well as the British standard BS6399 available. So we can actually provide the information over here, and we can also generate a report for the wind load calculation in the form of Word file. So here we have a Word file information regarding all the calculations, the formulae that have been used to perform the calculations, and we also can see here the calculated values for the pressure, windward and leeward pressure, and this is applied on the external itself face itself, so it only CPE values would be provided. Okay, so sorry, I'll just add one information for the Eurocode, and we can apply in both the directions the wind loads. And then the static seismic load also can be applied by automatically. You can also consider the eccentricities. Eurocode 8 is applicable as ASE and UBC, ABC, all these codes are available. Simply select the site-specific parameters. Even the approximate period can be automatically calculated by the program. Okay, and then you can apply the seismic load again in both the directions by using just one function. You can also see the base shear value even before performing the analysis. So here we have got show profile option. You can see the calculation for the story force, story shear, as well as overturning moment. This is available for wind loads as well, and if in case you're using wind tunnel test results, then those also can be applied. I missed to tell that in the wind load application. Okay, so we have got the static seismic load applied. We also have got response spectrum if you're into the dynamic seismic loads. Earth pressure load can be applied to basement walls and retaining walls. As per European standard, automatic imperfection coefficients are available. Alright, so that's about the loading. We can also apply temperature loads and settlement loads on the structure. After the loading is completed, then we can go ahead to the boundary. In the boundary, we can apply the supports, fixed supports or pin supports if we do not have foundation. And in case we have the foundation like we have right now, you can either provide the soil spring supports, we have pile spring supports as well, or we have got certain area springs option. So I would like to show this distributed area spring option, which is unlike other software solutions. You can actually apply the spring information, linear, tension only or compression only, and provide a modulus, a subgrade reaction over here. You can select all the foundations to which this vertical spring support is to be assigned, and then you can go ahead fix your lateral direction, so you can apply a stiffness 10% of the vertical modulus of subgrade reaction. Here I'm going to make a bigger stiffness to fix my X and Y lateral direction. So I'm selecting all my foundations and I'll apply the fixity for the X and Y direction. Alright, now further I can go ahead and convert my loads to masses, which is an option for automatic calculation of seismic loads. In other programs, we have to manually calculate the masses and apply, but this is an automatic option over here. Okay, then further even the diaphragms can be applied over here. The program will automatically calculate the center of mass. Then we have got the rigid region option as well, which will take care of the rigid zone between the columns and the foundation. So I'm selecting all this information and I'll click on OK. So that's a rigid region. Then I'll just auto generate the rigid zone option and all the offsets that I have applied. Sorry. So let me open. Okay, this is the analyzed file, but let me go to the pre-processing mode. Okay, and show the final structure that we have. So in the boundary conditions, we applied the rigid zone and we did the auto generation. Then further, we are going to perform the analysis. Now in the analysis, we have got the option to select what should be the mesh size. So as we have got 2D elements like slabs, we have got foundations, the meshing is important. So we can actually decide what should be the maximum mesh size. We can also provide the seeds to specify the different sizes of mesh. Now combinations. Load combinations can be automatically generated by the program depending on the code that has been selected. Okay, so for steel as well as for concrete, we can generate the load combinations automatically. Manual load combinations are also available. Next, we will move ahead to the analysis cases. Like I mentioned, in MIDAS engine, we can have multiple analysis cases defined. So you can actually have one analysis case without the foundation, one analysis case with the foundation. You can also have in the same model the analysis separately for steel, separately for RC. So we have several options available under one hood for just one model itself. So you can have a complete model analyzed at once or separately using the same model file. In MIDAS engine, we also have p-delta analysis, eigenvalue analysis, and buckling analysis. When it comes to industrial structures, crane load analysis is also available. And for flat slabs, we can also perform cracked section analysis. All right, so we can actually run the analysis and we can go ahead to check the results. Okay, so before we go ahead with the results, let me also complete the design part. Okay, so in the design part, we can get the design settings as per our requirements. Now in the design settings, you can select the code. So as for designing purpose, we have Eurocode, American and British standard available. You can select the demand capacity ratios for final output, and you can select which all rebars you would like to use for your RC. Then there is a checking control option wherein you can select again the number of checkpoints, and for options like in beam, RC beam, you can select if compression type of reinforcement is to be utilized or not. And then you can also select which type of member forces are to be used for the foundation analysis, design purpose. So all these options are available. And then you can also generate the load design groups automatically. So we have got auto generate design group option. You can assign separate member parameters to the different types of members. So when it comes to beams, columns, shear walls, you can actually select, for example, if you want the stress to be checked and what are the parameters for the stress, crack check is also there. Okay, so these options are there, and deflection check is also available. So you can select what are the parameters for this check. And you can even assign your own reinforcement to the structure. So if any one of you is performing a check or doing proof checking for other buildings, then you can actually assign your own reinforcement and then perform a code check where the program will provide you the results in the form of Word file. All right, so you can again create different analysis design cases. All right, now I'll perform the analysis and design. Now analysis and design is already performed because of time. So I've performed the analysis and design in this model file. When it comes to the results, we can see the results dynamically. So you can see this is the deformation result, the XYZ deformation. You can even see the deformed shape over here. You can see the maximum value on the screen. There is a legend available, very intuitive one, that tells us how much of the structure is at what deformed level. Okay, so that's about the deformation. Then you can also see the results like reactions. Now reactions you can see over here in the form of display, or you can even go to the table and get the displacement or the reactions or the bending moment tables. So that's also available. So there is analysis and deformations. Let's say, for example, you can actually do the selection of some nodes and see what is the deformation of those nodes, or you can even select all to see the result for all. Okay, so I'll initialize the structure, and you can also see the results of applied forces and even the truss forces. So axial forces in truss, so we have used braces for that. We can see that result. Then bending moment diagrams we can see for our structure beams, and we can see the axial forces for our columns as well. And similarly we can get the results for the walls, so axial force for the wall, and you don't need to actually even assign any wall ID or pier ID, so time is saved over here. Then when it comes to the pressure for a foundation, so we can see the pressure values as well, the the subgrade stress. All right, and yeah, that would be it regarding the results in the image in the contour form. All right, now further let's look into the design results. When it comes to design, the program can give us the results directly by just double clicking on status. You can see which all members have passed, which all members have failed. So we have got a legend that gives us that information, and very intuitively you can understand which members have passed or failed and why they have passed, why they have failed. Again, you can see that information. You can double click on the axial ratio, bending ratio, double shear ratio, and so on, and look at the legend. So if this legend is showing somewhere above 1, then of course we have got a failure over there. Okay, and we can also see how much for, let's say, isolated footings are failing. So we can see if any shear failure is there or not. As you can see, this is the two-way shear check, punching shear check at 2D distance, and we have got punching shear check at the face of the column as well. There is the rest of the check as well. So X direction check and Y direction shear check is available. So all shear check is satisfying. And yeah, we can also look at the bending results, and we have got options for bearing capacity results. So all these options are there that the program has checked. Okay, and finally we can get the output in the form of Word files. So you can actually see the design report generated, be it a summary or a detailed one. So let me go for a detailed one, and I will select, let's say, one steel column. Okay, and I'll select one concrete column, one concrete beam, one steel beam. Let's take one brace as well, and we can take up one slab, RC slab, and let's also take one isolated footing result. And we have matte foundation as well, so matte foundation result also. So we are going to be generating right now a Word file detailed calculation report. Okay, by the time the report is being generated, let me take you back to our PowerPoint presentation about the optimization. Now, as you remember, we had applied the rigid zones for the columns and the beams, and same thing was applied to the beams and columns and the foundation. So that's about the optimization by using shape offset. You can also include uh, deep beams by using plate beam type of member. In other programs, you have got plate members for deep beams, but you cannot perform a beam design out of it. So we have got that option. We can perform the beam design for a plate beam type of a member, and that is applicable for wall columns as well. Design codes. So we already saw what all design codes are available in MIDAS engine. And now we'll come to the high quality output. So high quality output is generated over here. Let me just check. Yeah, Word file is generated at the bottom. This is the Word file generated. You can see this is the beam result. You can see the reinforcement arrangement. So it's not just the area of steel, but also the reinforcement arrangement that the program can give. And this arrangement is also under your control. So you can choose which diameters of bars are available on site. As per the practice, you can see the moment is checked. You can also see over here, these are the sub clauses as per the Eurocode. So from those sub clauses, these formulae have been taken. So that's about the moment check, and you can also get the shear check for the beams. So after the moment check, there is shear check available for all the parts of the beams. You can choose how many parts you want to perform the design for. Okay, so that's about the shear check. And further, I will be sharing with you this Word file for your kind perusal. So you can see the creep check is also there, and we can see crack check and the deflection check. So you can see there is a deflection check, short term and long term deflection check as per the European standard. And then we have got the column design result. So we get actually a PM interaction curve as well for the column design, and we will get all the calculations as per the practice, as per the code. So that is there. Then further, we have this two-way plate type of element, slab element. So two-way plate, the design of it is also provided, all the equation clauses, and you can see there are stress checks also. Creep is also checked for the slab. Crack width check is also available for the slab. Okay, that's it. Then further, we have got the design for matte foundation. So you can see the rebars applied. And then further, you can see here that matte foundation moment check is there, shear check is there, then stress check is also available, punching shear check and two-way shear check, one-way shear check is also available. Then creep is also checked, so long-term effect is checked. Crack width check is also there for the matte foundation. Okay, and finally we have got the steel one, the steel beam. So again, the steel check is available. The classification of the flange is done, for the web is done, and so on. So basically, a very detailed calculation sheet is generated by MIDAS engine, and that's what I mean by high quality output. So I'll go back to our presentation right now. And this is what we saw. We can get a summary report as well as a detailed design report, which includes the sub-clause numbers. And we can also generate a separate report maker. So let me show you how this is done. So there is a report maker in MIDAS engine. You can create your own template for what all inputs or outputs are to be provided in a particular project report. This can be saved and you can use it for all your projects in future. You can have complete control on the font size, the text size, that's the font size itself, the shape and the thickness and bold or not, the tables, which all diagrams and so on. Sorry. Okay, so finally, this report maker that is generated can be exported into a Word file. So once you have got all the templates generated, you can open that template and directly generate the entire project report as per your practice for each and every project. So I believe it would save a lot of time. This actually also means if you have any modification in the same model file, then you do not need to work on the project report again. The entire project report will be modified as per the latest model. So that's about the high tech output in the form of Word file. Let's also look at the drawings. So MIDAS engine, yeah, This is the MIDAS engine software, right? So from MIDAS engine, we can generate the drawings as well. So let me open MIDAS drawing software. MIDAS drawing is our detailing tool wherein you can actually get the information for the foundation plan, let's say. For each and every floor plan, you can get the entire information. For example, the reinforcement arrangement, the size of the foundations. So once these drawings are generated, we can see the output. And okay, so we can place our foundation plan over here. All right, so you can see this is the foundation plan. You can see over here the column and the reinforcement arrangement for our isolated footing, our combined footings, our mat foundation as well. You can see the groups as well. You can also look at the structural plans. So there are center line plans for the column and for any structural elevation. So let me create a structural plan over here. At the bottom, you can see a red line, which actually shows the progress of our drawings. So you can see this is our floor plan with the reinforcement, with the groups of the slabs and beams and columns. I'll also generate the information using a structural section. So I'll create one structural section over here. I'm using all the AutoCAD commands itself. Okay, so I chose, okay, let me create one more section. This should give us the information regarding the okay, so I'm selecting the centers and the direction. So we get basically the drawings for our steel sections as well as the reinforced concrete sections. Yeah, so here we have. Okay, so if we select the correct location of our section, then we'll be able to see the information for all our steel sections. Okay, so this is how we can see the result for our steel sections. And we can also generate the rebar arrangement. So let me show the rebar arrangement for beams. The program is also capable of providing the bar bending schedule. So let's look at that. Firstly, the longitudinal rebar arrangement. All the development lengths, splice lengths, hook lengths are taken from the Eurocode itself. If anything is required to be modified, we can do the modification of the settings. So there are rebar arrangement settings available as per Eurocode, the code which you have used for the design purpose. You can get a key plan as well for the beam which is in concern, and this is the bar bending schedule. So you can see the rebar quantity table. You'll see the rebar shape, the rebar length, rebar size, quantities, and the total length. Okay, let me generate a bill of material as well for all our members, steel as well as RC. This bill of material is available in the form of Excel sheet. Okay, so by the time the Excel sheet is getting generated, let me go ahead in our presentation. Okay, so we just saw the high-tech output. Now let me talk about the technical materials available on site so that you can easily start learning how to use the software. We have video files available on our website. Our technical support engineers are all civil engineers, so we can easily get your queries and we can get back to you quickly. So within 24 to 48 working hours, we can get back to you with a solution. Okay, so before I conclude, let me show show the output for the Excel sheet. So the output is getting generated, Excel output. Okay, so by the time the Excel output is getting generated, let me do some conclusion over here. So MIDAS engine is our all-in-one software solution wherein you can perform the analysis, design, drawings of steel as well as RC structures. You can have the superstructure as well as the foundation. So we have analysis, design, drawings, even report generation is available. We have CAD tracer tool for the modeling. So there are some advantageous modeling features. Node element modeling method is also available and CAD based modeling method is also available. When it comes to applications, as you can see, RC structures, be it multi-towered structure, spatial structures, irregular roofs, then steel structures, steel warehouse structures, stadium structures, even general structures such as elevated water tanks, transmission towers can be applied. Advantage is that you have all types of foundations and substructure design features. We have high quality output generated in the form of Word file, which can easily provide you information if the result is okay or not good. The report maker also can include the information about the designs directly, if the result of any member was okay or not good. So a major part for your customized submission report will be completely done in MIDAS engine. Then we have got drawings generation and the bill of material. So this bill of material is generated. It's still taking a little time here. There are many members for which the program can provide a detailed bill of material. If we choose not to have so much of detailed information, it will be of course faster. Basically, this is the output wherein we can get the result of each member, each group of beams, columns, shear walls. You can get unit length and you can get the quantity of each type of member, and then the total length. You can get concrete volume in meter square, meter cube, sorry, and you can get rebar, rebar in tonnage, rebar weight in ton, and then the formwork in meters square as well. Okay, so let me check. Okay, this is still getting generated. Okay, so that is it regarding MIDAS engine software solutions.